Hi there. Today we're continuing to study chemical formulas and formula composition. And they approach the third category. These connections are binary, meaning there are two elements in it, but these are covalent connections that consist of nonmetals. Only nonmetals are included in this context? So first and foremost, I would like to explain that in this particular instance, it is customary to indicate prefixes in systematic names, which enable the indication of the quantity of a specific element present in a given compound. These prefixes, they have their own digital designation, and in this case, there is a correspondence between the prefix and the numbers. Mono is 1, D is 2, tri is 3, tetra is 4, and so on up to deca. Normally we have over 10 of these particles. There are not actually a lot of these compounds in principle. However, I would like to provide an explanation. For example, if it is a compound consisting of both carbon and oxygen, which is commonly referred to as a CO compound, then in this case, our name for it will sound like this. Carbon monoxide is a colorless and odorless gas that is highly toxic to humans. However, just how incorrect would it be in this specific case? That is, how utterly impossible it would be, accordingly, monochromatic, carbonaceous, and accordingly, once again, without a shadow of a doubt, without a single shred of doubt. Monoxide, that type of name would be incorrect. Hence, when we have one element and one of each element, there is no need to use mono in this particular case, in both these cases. Well, now let's give examples of such connections. All right, let's have our first formula. What will this connection be referred to as? It will be referred to as SO because there is one oxygen and two nitrogen atoms involved in it. The name SO is derived from the chemical symbols of oxygen, O, and nitrogen, N, representing their presence in the connection. D corresponds to this pair. Monophonic corresponds to this single unit of sound. But I'll remind you that we don't write the word unit here, so in this case it's implied. Okay, let's proceed to the next item on the agenda, which is the formula. The formula we're dealing with here is NO2. Okay, based on the presence of nitrogen 1, we can conclude that the compound is nitrogen dioxide. Okay, great. Moving on to the next example. Suppose we have a compound with the formula P2O5. It would be referred to as phosphorus oxide. At that moment, it is identified as phosphorus 2-diphosphorus, a compound consisting of multiple phosphorus atoms. So, an oxygen 5, so we have fenteoxide, so we have an element called oxygen 5, which combines with another element to form fenteoxide. Here's how the title will be. Okay, now let's attempt to perform the reverse task if this connection is called in this manner, as shown. Sulfa, hexa, please provide additional information. Vale. In the ranking, sulfa occupies the first place. Hexa is the corresponding prefix for fluorine, and the numerical value 6 will be present in this context. Consequently, we engaged in a collaborative effort and devised this formula. Okay, let's explore the situation in which we are faced with phosphorus trichloride, a compound consisting of one phosphorus atom and 3 chlorine atoms. So in the first place, we have phosphorus chlorine in the second place, and here we will have 3. Here is the manner in which the formula will be constructed. So in order for you to be able to name and create such formulas yourself, you need to utilize these prefixes for such compounds. But they are mainly used for covalent compounds. For other prefixes are used only in organic chemistry, where the name of organic hydrocarbons is formed, which will also be associated with prefix endings. But we're currently working in inorganic chemistry, where they use names and prefixes accordingly. I hope we've got you covered on how to compose formulas for such compounds, and it's clear. That's all for today. Goodbye.